Good afternoon, everybody, and welcome to the 65th talk lunchtime seminar from the Institute of Agricultural Engineers. We've been undertaking these talks, hosting these talks since 2020, generally once every month. And I've got great pleasure today in introducing a talk from the remote sensing application consultants, a team of a small team who have been working on crop mapping certainly since I've been involved with them in 2014-15, I think. And I've got great pleasure introducing Mike Wooding and Tim Pearson, and I believe Mike is going to start. And before we do that, just to remind everybody of the house rules, and that we will keep you muted during the talk, which is going to last about 40 minutes. And if you've got any questions, please put them in the chat and we'll get to them at the end of the talk. So it's a great pleasure again to introduce remote sensing application consultants. Mike Wooding, please.
Right, I'll just try and share my screen now to get things going here. That's it. That's good. Oh, well, good afternoon, everybody. Myself and colleague Tim Pearson, as Nicholas has told you, are from Remote Sensing Applications Consultants. We're a small Hampshire-based company which specialises in agricultural applications of Earth observation satellites. For more than 30 years now, we've been working in the UK and internationally, involved in research projects and delivering customized solutions for a range of private and public clients. In the UK, we worked for the Rural Payments Agency and Welsh Government for many years, essentially as their spy in the sky. We were using satellite images, checking up on farmer subsidy payments. We don't have any plans to come clean about that today, but rather are pleased to have the opportunity to talk about the national crop map that we produce in association with the UK Centre for Ecology and Hydrology. This is a unique, detailed field map of nearly 2 million parcels in Great Britain, which has been produced since 2015. In the first part of the talk, I will be explaining how we carry out this crop mapping within the framework of the UK CEH land cover map and the satellite data that we use to do this. Then in the main part of the talk, Tim will be focusing on Crop Map Explorer, a new platform that we have developed to enable visualizations and analysis of the information contained in the 10-year archive of crop maps. So our starting point for crop mapping was the UK land cover map produced by the Centre for Ecology and Hydrology. This UK master map, UK land cover map, uses OS master map data as the basis for a parcel-based map of 22 different land cover classes. These include many different types of natural and semi-natural vegetation. But when we look at the agricultural areas, such as we have here, we see that most of the land is either classed as arable in brown or improved grassland, which is light green. Also prominent here are deciduous woodland in red and water, which is blue. So simply put, the aim of what we were doing in this project has been to attribute the arable and the improved grassland classes within this annual crop information. So here we are, starting with the UK land cover map. This is our crop map called Land Cover Plus Crops. So we use the European Space Agency Copernicus satellite data to produce this every year. We use both Sentinel-2 data, which is a as a conventional optical satellite, and Sentinel-1 data, Sentinel-1, which is a radar satellite. The field boundaries are based on OS master map with the field subdivisions where there is a multiple crop within that field in a particular year. We map the main winter and spring arable crops, and only a limited number of the mapped crop classes are shown here, but I'll be expanding on that a bit later. So land cover plus crops is available from 2015, actually. Here it says 2016. We did the mapping initially in 2015, and we're just in the process of producing the map for 2025. So we have 10 years of crop rotations within the map. So in terms of the satellite data that we're using, first of all, we use this optical satellite, which is the Sentinel-2 satellite, which measures the ground surface reflectance in the visible and near-infrared wave bands. This false color simulation that you see here includes the infrared wave bands, and vegetated areas appear orange. So this satellite orbits at 786 kilometers. Every orbit takes 100 minutes, and it acquires these strips across the Earth's surface. They're quite wide strips, 290 kilometers wide, with a 10-day repeat coverage at a spatial resolution of 10 meters. Now, as there are two of these, the Sentinel-2A and Sentinel-2B, we're able to obtain 5-day repeat coverage. But there's a big but about all this, and that's that we only see the surface when there are no clouds in the way. So that is a big limitation of optical satellites when we're looking to have any sort of multi-temporal data for mapping changes. And indeed, it's quite rare to have more than 3 or 4 good cloud-free images covering the whole of Great Britain every year. And we don't know when that's going to happen. It may be that we don't see an image, for instance, in June, which is a key period. So the other satellite, this has drawn us to have a lot of interest in a radar satellite. It's the Sentinel-1 radar satellite. The radar satellites transmit a pulse of microwave energy down to the Earth's surface at an angle and generate images from the return signal. But of course, these devices are all-weather devices, so they're not affected by cloud, and so we're able to produce a time series of images. And you see here, they have 5 little images covering an agricultural area. You can see that the images themselves have changed in that time. So there is something happening on the ground that is affecting the backscatter signal. So we have an area of growing crops. So this sort of indicates possibly that the growth of the crops is affecting the sort of return we're getting from the surface. And indeed, when we first, so when we look at the sort of challenges of using satellite data for national crop mapping, we're looking at mapping arable crops through well-defined growing seasons, so which are long for winter crops and shorter for spring crops. But there's a lot of variability in terms of how the crop appears at any one time, and hence the spectral signatures and the radar backscatter of these crops. We have climatic variability north to south, east to west, variability in sowing dates and establishment. And there are year-to-year weather conditions which affect crop growth and harvest timings. Also in the crop mapping, we actually have to take account of multiple cropping. We know that in some yields, fields have 2 crops in the fields as well. So we have to map these parcel splits to record that. Using optical satellite data, there are a few crops that we can really map easily with optical data. One of them is oilseed rape. If we happen to have an image in April, May, for instance, when the crop is flowering, but a time series of images are required to discriminate a wide range of crop types. And this is not easy. It's using optical data because the acquisition is haphazard because of periods of persistent cloudy weather. Clouds and cloud shadow also affect the images. So we set off in this project when we first started this, we realized that if we were going to have an operational system, we'd have to be using radar satellite data. And so the first question we had was, can these measurements of surface roughness and moisture really provide suitable discrimination of the different crop types and conditions? So initially we looked quite a lot at the backscatter data from the Sentinel-1 satellite. Here you can see some plots for a particular field of the two different polarizations of the satellite. You can see the intensity returns. And when we look at a grass field, you can see there's a good deal of consistency in the backscatter of that field. So, so a grass field is not growing. This is a grazed grass field, not changing significantly, and we're getting a stable situation. But when we start looking at crops, we see there are sort of temporal changes that are happening. And when we look at a crop such as winter wheat, we can see from from May to July, we're having a gradual increase in the backscatter. So that is saying the roughness, this sort of roughness, as the crop is developing, the ears are developing, and as the crop is drying out, we're getting different backscatter from that. So we're able to sort of come up with sort of signatures for different crops. In this case, we see that when we go through, this is sort of late crop. Once the crop has been harvested, then obviously we can have lots of different situations. We can have stubble and bare soil and things like that. But that's the situation for wheat. But if we look at another crop, winter barley, we can see that winter barley has a very distinctive increase in backscatter at the time of strong ear development in June. So we're seeing this has a distinctive peak there, and it drops off when we get to a ripe crop. So what we see on the radar is a combination of roughness and moisture content, and so this may be coming into play. And it's quite interesting that if we move now to a spring crop, we can see that this particular peak moves further into on the time frame as it's later on in the spring crop. So here essentially we're seeing that these images from these graphs, we can see that there is a sensitivity to cropping, and we've been able to exploit that with our crop mapping. So the methodology that we employ involves the use of a time series of radar images. Here I'm just showing 5, but indeed we have images with 6-day repeat through the whole of the crop growing seasons that we can use. And we use those in combinations with a land parcel map and a ground data. So we're collecting approximately 1,500 ground data points over the country to carry out this mapping every year. And we're using a cloud-based processing environment for carrying out the classification of the crops to identify these crops with our parcel database. So that sort of classification has moved on a bit, and now we're using some AI techniques involved with that. So some of it is putting a lot of things into a black box and getting out better results than we could from using a few temporal graphs and things in the past. So the classes we have, we're mapping winter and spring crops of wheat, barley, and oats. We map oilseed rate. We map the main other arable crops such as field beans. We actually separate winter and spring field beans, potatoes, peas, sugar beet, maize. Our other class is really a lot of vegetable crops, particularly because we're unable to map those because they don't have a recognised sort of growth pattern that we can use satellite data for. We've had a lot of difficulties in actually assessing the accuracy of the crops. We have more difficulty in assessing the accuracy than producing a map. That's because a lot of the data sets that we've obtained have their own inaccuracies, and because we would need more than we use for the ground truthing in our classification to get a good accuracy of result, because many of the crops are available in smaller numbers. We need a large number. So we've carried out lots of exercises, but we come down to sort of the indicative accuracies, and we are very accurate for oilseed rape. Probably 99 fields out of 100 are correct. When we're talking about correct, it's obviously getting it right and missing crops as well. So overall, an 99% accuracy. The winter crops are pretty accurate, 97, winter barley, winter wheat. Spring crops, 95%. Oats, we have a little bit of a problem with, we're down to 90. And then when we're dealing with the other crops, it's around 90 to 95%. Grassland is good, and recently we've taken on board solar panels, and I think we may be getting better than 98% now on solar panels. So that's another class that we map. So overall, this is what I've been, in summary, this is what I've been talking about. It's Land Cover Plus Crops is an annual crop map product, the only data set of its kind in Britain, covering Great Britain. The 10th edition for 2024 is been available for a while, and the 11th edition will be available very soon. The product is licensed to government agencies. It's licensed by the Centre for Ecology and Hydrology through the Centre for Ecology and Hydrology to government agencies, water companies, and other agricultural companies who are using it for a range of applications. We'll look in more detail at these applications in a minute, but they include sort of catchment sensitive farming, hydrological modelling, and crop areas and statistics, plant health and crop science. So that's the introduction to this crop map product, and now we move to my colleague to talk about perhaps the more exciting things about how we now have developed a system, a platform for analysing these products that we've been producing. So I think I've got to stop sharing now, and hopefully Tim will be in a position to take over from here.
Right, so on top of the crop maps that Mike has been talking about, the Land Cover Plus portfolio has been expanded in various ways over the years, with new products relating to different aspects of sustainable agriculture. So just before I get into talking about Crop Map Explorer, our platform for seeing all this data together, I'll explain these in a bit more detail for you. So first of all, responding to an increased interest in low carbon farming, Land Cover Plus Winter Greenness is a satellite derived layer that shows the maximum degree of green vegetation cover that's observed within parcels during clear sky opportunities in the winter months of each year. So for fields sown with a main crop in the autumn, this relates to the emerging winter cereals or oilseed rape. And for the other fields, is hopefully relating to some sort of sown cover or catch crop that's in the field prior to a spring or summer crop later on. So this product is derived solely from optical satellite data. As Mike mentioned earlier, that there are difficulties in seeing through the clouds using optical data. And for this reason, viewing opportunities, particularly during the winter months, November to February, that we're interested in for this product, these opportunities are rare. So compilation of numerous partial observations is necessary in order to complete the national picture and produce this product. What it shows is for each parcel, an index relating to the greenness. It ranges from 0 for a bare soil field. So that's a field that we never saw with any kind of green cover during the winter months, through to 1 for a fully vegetated canopy in any one of the images that we obtain for that field during the winter. So winter cover, this product helps us to understand one aspect of carbon sequestration. Another aspect of this is permanent grass, of course, and using the growing time series of crop maps that we have, we're now able to identify those fields that always have grass. And so you can envisage another product, which is a permanent grass map coming out of our Land Cover Plus portfolio. Then we have a preliminary crop map, which is an early version of the main crop map, showing just winter cereals and oilseed rape, which are another form of winter cover. So in the process of producing the main crop map, we do generate an early release, which is published in September, which just shows the fields that we've identified with these 4 classes. So winter wheat, winter barley, winter oats, and oilseed rape. Then as the archive of crop maps is growing, we have an increasing amount of information about the cropping history, and that enables us to categorize fields by rotation type. So we can assign classes based on classic combinations of crops that feature within the cropping history for individual parcels. And we can also count the occurrences of specific crops within the time series in a certain parcel. So we have various ways of mapping different rotation regimes. The UK Centre for Ecology and Hydrology has also developed some products based on the Land Cover Plus archive, including one estimating average fertilizer and pesticide applications on a per parcel level, and a model for soil carbon storage, which we worked together on in developing a few years ago. Now, to further capitalise on the Land Cover Plus portfolio and support sustainable agriculture, RSAC and partners have recently developed a spatial database for the organisation of our parcel level observations and tools to facilitate their visualisation and analysis. These are combined in Crop Map Explorer, which provides visualizations, geographical summaries, and detailed analyses of parcel level time series cropping information. Note that this tool is intended mostly for retrospective analysis applications and not things like precision agriculture that require real-time monitoring. I'll speak more about the use cases later on. We're also continuing our work to experiment with new satellite-based methodologies and derive additional parcel level observations that could be added to the Explorer later, particularly around grassland management and tillage detection. In terms of grassland, our aim is to provide information on pasture, such as management intensity, based on the number and dates of hay cuts or grazing episodes per year. And this is valuable information for informing environmental policy development and other uses. So far, we've conducted a feasibility study into this approach, into our methodology, which shows good promise at regional scale, but we've yet to scale up to a national level product. For tillage, we're looking to observe and categorize soil surface disturbances, tillage, but also other field management activities potentially, also while the field is empty, when it doesn't have a crop growing in it. And this is needed to inform soil carbon emission quantification and support regulation and monitoring of things like the SFI minimum or no-till measure. So we have a database with a structure able to accommodate multi-annual crop map data and other parcel level observations, including for agricultural parcels whose boundaries may have changed over time. It currently contains nearly 2 million parcels in England, Wales and Scotland, each attributed with annual cropping, annual winter greenness values and other topographic attributes. With over 40 million records so far held within the database. It's updated every year when new crop maps are released. It's built using Postgres with PostGIS and is hosted in the cloud. Our dashboards enable cartographic and statistical display of the parcel level data and observations stored in our database, visualization and query of parcel specific information, local and regional aggregation of data, either by Water Framework Directive catchments or administrative areas such as counties, districts and parishes, and analysis of trends and correlations within the data. It is also hosted in the cloud and is accessible via a regular web browser, simplifying access to satellite-derived information for users without any Earth observation or GIS expertise. So CropMap Explorer has 3 interfaces currently, which I'll now take you through using some short videos that show examples of the kind of visualization analysis that are currently possible, starting with the cropping dashboard. So you can see in the left-hand panel here, these are the means for navigating around the country and looking at the data in manageable chunks. So using clickable maps of progressively greater scales, it's possible to select an area of interest. So here I've selected the Welland Water Framework Directive Management Catchment, which runs through Rutland. There's Rutland Water showing here. So if I stop the video running, I could equally have used administrative areas to select a different area of interest, but we're sticking with a catchment for now. And then this drop down gives you the opportunity to select a year of interest. So we're looking at the 2024 data at the moment. So the map shows the crop map for this area, coloured up with the crops shown in the list here. So this is actually an area where all 16 classes of our crop map are represented. Including both of the field bean classes. So when the cursor is put over the map itself, you see a pop-up appears that gives the crop growing in the fields selected, and also the field's area. Then over on the right here, we have charts which summarize the data displayed in the map. The pie chart represents the year of interest, the year selected, and these columns show how the distribution of cropping has evolved through the whole time series. It's possible to isolate a single crop. So the example here I'm using is oilseed rape, and the graph here is reduced just to that single crop, and is showing how the area under oilseed rape has declined quite markedly over the period that we have the crop maps for, ever since the very wet autumn of 2019. And we see in this area, at least, there's not been a recovery from that reduction yet. Okay, so back to the navigation maps on the left, we can zoom in to an operational catchment, the upper welland in this case, and then further into a water body, an individual water body. And each time we zoom in, the charts on the right update to represent just the parcels within the newly selected area of interest. And at this level of zoom, you can see in a bit more detail the individual parcels represented by the crop map. They're overlaid on this backdrop map in this instance. We can also take one further level of zoom, where when you click on an individual field, then the other fields that belong to the same farm are isolated, and again the charts update to display. One further feature here to highlight is that at any point the current view of the dashboard can be downloaded as a PDF for use offline, away from the desktop, perhaps out in the field or somewhere else without an internet connection. Right, so that's the cropping dashboard. The winter cover tab, again, we're in the Welland, the upper Welland catchment. And the main map display here is showing the winter cover map that I described earlier. Here we've just got 3 categories of greenness within the fields. So bare, partially green, and mostly green, let's say. The fields that are grey in the view here are the winter cereal and oilseed rape fields, which we assume to have developing green cover and are of less interest for this particular application. Also included in the grey class are the solar farms, which we can't quantify in terms of greenness. There's a list here that enables individual crops to be filtered if you just wanted to look at one particular group of fields. And this time the pop-up, when you point at an individual field, is showing the crop that will follow whatever the cover crop represented here will be, along with a numerical representation of the winter cover. And this is present also for the fields shown in grey here. It also shows the average slope of each parcel and its distance to the nearest mapped watercourse. So there's a partially green Springfield bean field. There's a layer control function here, which allows us to look at 2 other layers in the map window. The first is distance to water. So here we're seeing for each parcel the distance to the nearest watercourse from dark blue adjacent to water to pale blue furthest from water. And the second layer here is the slope product. This is the average slope of fields from relatively flat in yellow to relatively steep in the deepest orange and red shades. And that same information is shown in two histograms in the right-hand panel using the same color schemes. So again, these charts can be used to filter the information shown on the dashboard. So here I'm selecting the steeper sloping parcels. So those are isolated in the map. I can then just pick out the steeper sloping parcels that were bare in this particular winter. As you can see, there are 3 of them showing up here. Just turn the distance to water back on. And that highlights that we have one particular field here. It's a field that went to spring barley, which during the preceding winter had a relatively low winter cover, what we consider to be essentially bare, even though it's almost 7 degrees of slope and just a few meters away from this the reservoir to the south. And then there are a couple of other parcels for which we can also get the information. There's another spring barley field here. And a spring oat field just there. Okay, and then finally, in terms of rotations, again, starting from the Upper Welland operational catchment, but moving to IAgrE water body. What's showing here is a map showing the number of occurrences of the crop in the selected year in the preceding time series, ranging from 1 for unique crops in the time series for that particular parcel, through to 10 where the same crop is occurring every year. Now, at the moment, this map is rather skewed by the presence of permanent grass, but we can use the crop filter at the top to eliminate grass along with solar farms. And once those are removed, looking at just the arable crops, we see that the majority have low recurrence figures, 1 to 6 essentially, and hovering over the parcels we can see the actual cropping history for individual parcels that confirms a good variety of crops in many cases. Over here there are some deeper orange fields representing high numbers of recurrences of the same crop, and indeed these are fields where maize has been grown year after year. So perhaps these highlight something that would be worthy of investigation by particular stakeholders. We can also display another representation of crop rotation. In this case, we're looking at the period since the period since the crop in the selected year last occurred in the preceding time series, between 1, when the same crop was grown in the previous year as the current year, through to never, or at least 10 years for very unusual crops. We can filter down just to the 1 fields in this case, and indeed when you look at the cropping history, you can see that the top 2 crops in the list are the same in each of those instances. So this dashboard also allows us to look at individual crops. So for example, if we wanted to look at oilseed rape fields, which should never be grown, oilseed rape should never be grown in the same field 2 years running. And indeed, from this information, we can understand that all of the oilseed rape in this catchment is on a 5 or 6 year rotation, which is good to see. Finally, one more thing that I'll show you can be done in this dashboard is to look at grass and then focus just on fields that have always had grass. And that is essentially producing a map of the permanent grass within this catchment, as the cropping history confirms here. Okay, so we envisage a wide range of use cases for all of this. Primarily the information provided by existing and proposed Land Cover Plus products and Crop Map Explorer can enhance agronomic advice and support monitoring of sustainable agriculture initiatives. We initially aimed Crop Map Explorer at catchment managers and advisors and catchment sensitive farming officers within water companies, who will always need the kind of objective, detailed and synoptic views of agricultural land use within catchments that we're providing to support their obligations for providing safe drinking water and meeting environmental objectives. We'd expect such customers to be making daily use of Crop Map Explorer. Beyond water companies, we're aware of many other potential customers, including land surveyors who may wish to identify suitable sites for agri-environmental schemes, agronomy service providers who might want to formulate appropriate advice for farmers, suppliers of agricultural inputs with needs for market research, for example, in terms of identifying areas where particular crops are being grown, insurers who need evidence for assessing claims, and also those involved in carbon accounting and life cycle analysis, where up-to-date information about sequestration and emissions potential is of value. The tools might also be useful in other sectors, for example, as a record of solar farm expansion. And I'm sure there are many other uses to which these tools could be put as well. The products and dashboards can additionally support a range of institutional needs. DEFRA has its own catchment sensitive farming program and of course implements ELMS with the sustainable farming incentives, etc. Crop Map Explorer could be used for both advising and monitoring in the context of these initiatives, as well as others in the framework of the 25-year environment plan. And they also have application potential in the context of carbon credit trading. Through contacts with water company staff, we've understood that Crop Map Explorer could help them in many uses, many applications, including informing routine interactions with farmers and landowners with better background information, identifying agricultural practices that may pose a threat to water quality in particular catchments, undertaking water quality risk assessments and tracing the sources of diffuse contamination, coordinating catchment sensitive farming interventions across multiple farms within a wider catchment, taking advantage of the synoptic view that the dashboards offer. Optimizing water purity by planning water abstractions in catchments with cropping that is likely to mean that less post-abstraction treatment is required before water can be put into the pipe. And verification that catchment sensitive farming measures that have been advised are being implemented as promised. The database could also provide more objective and quantitative inputs to hydrological models, which we understand are often very difficult to obtain. So Crop Map Explorer is now available as an operational subscription service. We offer licenses that currently provide access to all 10 years of the Land Cover Plus crops and winter cover products throughout Great Britain, and of course the 2025 products will be added in a couple of months' time. The Land Cover Plus crops with winter greenness are also sold as licensed data for those who have their own GIS systems and would prefer to use them in that way. But information on all of our products are available on our websites, and by getting in touch with us for more information at this email address. So that's the end of the presentation. Thank you for your attention. Mike and I'd be happy to answer any questions that you have at this stage. Thank you.
Well, thanks, Mike, Tim, for a great presentation. I mean, when one considers the technical achievement over the last 10 years, I mean, it's incredible, really, the amount of work that you've put in. I have got some questions which I'd like to just take in order now. Right. Please, this is from William in Coventry. Please, what is the use of the distance from water feature? Surely not related to pipe irrigation or drainage.
We've included the distance to watercourse primarily from a catchment management perspective, thinking about runoff risk. So when considering the potential threat posed by a bare parcel, for example, in winter, in terms of potential sediment runoff or also leaching of chemicals into watercourses, the proximity to water is one of the factors that needs to be considered, along with slope. So that's why it's included. So there's the option to include that in any sort of analysis for those who wish to.
Okay, thank you.
Thanks, William, for the question. I have a question actually, and it's about the future. I mean, you know, it's interesting to consider the amount of information that lies beneath cropping information, all of the inputs that have gone in to 10, 12 years of cropping across the whole of England and Wales. But what about the future? What are satellites going to be able to tell us going forward into the next 10 years?
I mentioned two products that we're working on, which hopefully will come to fruition at some point in the near future. We're very excited about the possibility of mapping tillage and identifying, well, even to the extent of discriminating different depths of tillage, and that will be the holy grail. So that's one thing that we're hopeful will come to fruition. Mike, do you have any?
Yeah, well, also what we've been showing you here is really parcel-based data. So we're really we're just looking at characterizing or attributing a particular parcel with a crop type or with something else. But of course, the other very interesting area is to look at variability within those parcels, and so there would be possibilities, say, for once we've identified the wheat fields, let's say, we could be looking for which fields have been in that year were affected more by something like rust, some form of rust or something like this. So we could be looking at crop growth variability within these fields and different diseases. We could be characterizing these parcels in terms of those sort of factors. So that is, it doesn't necessarily require new satellites. This is something we could be doing now. But really the whole problem, I think, is getting enough satellite data, you know, to do with the optical satellites. If we could, and unfortunately, we can't change the fact that we have cloudy weather. Even with 1 or 2 satellite systems, such as the Planet systems, giving daily, you can get daily satellite coverage. You still have periods of 3 or 4 weeks in the British climate where you don't get images from those systems either. So yeah, we do have potential for extending this a lot further, I think, by mapping within field variability, and that's something that we are looking at now. We're starting to look at that. But as with a lot of these things, there are lots of things you can look at, but it's finding the proper customers for that. And it's so we think we have quite a nice data set now that lasts over 10 years, but we're still wanting to expand our customer base a little bit and get a bit more money from our customer base to do some of these other more exciting things, really. So yes, that's where we stand at the moment.
Yeah, and I think it's fair to say, Mike and Tim, that as a product, it's fairly unique, isn't it? We have not come across another product like this in Europe or in the United States.
Well, our crop map was the first national crop map produced, parcel-based crop map produced in the world. So it was the first map using satellite data to produce a crop map in 2015, and still I don't know of many other countries. I mean, I can't actually tell you a country that I know do this at the moment. So yes,
there are some attempts with a rather limited set of crop classes, rather sort of broad classes of crop groups. But yeah, in terms of our 16 classes and the accuracy that we can map all of the parcels, I think we're still unique.
Yeah, I mean, one application that springs to mind is life cycle assessment. Because you've got the base data for that, and I know that's very, very topical within the food chains, and in the the way in which agronomic standards are actually derived from the cropping, working its way all the way up to food standards. So that's very, very interesting territory.
Yes, the sort of growing interest in sustainably sourced ingredients could potentially, yeah. I mean, the food processors and suppliers are increasingly in need of information about where the crops are coming from and what else is happening in the same fields during the year.
Yeah. Okay, another question. Practically, in terms of the availability of this product, if you actually wanted to access it, how do you do that?
Well, the land cover crops, land cover plus crops is licensed through CEH. So the Centre for Ecology and Hydrology is the licensee of the data. So really, it's you can go to the CEH website and obtain information on how to request information on licensing the data. The product, the Crop Map Explorer product that we've shown you, is sold by RSA directly through RSCC, and we offer licenses for that. There is some flexibility on pricing related to the sorts of users we have. So if there's interest in that, I would encourage people to get in touch with us about that. Details of the product are on our website that Tim has told you about. So at the moment, we really it's concentrating more on water companies. We have some water companies who are customers for our new Crop Map Explorer product, and we're looking to expand the customer base of that, getting more exposure, such as this meeting. So it's been good to have this meeting to show this off a bit more, because it is quite a new product, and we haven't actually been promoting it too much so far.
Good. Thank you, Mike. Well, if there aren't any more questions, we've got 5 minutes left. I can't see any more. If Sarah's there and if I'm looking in the wrong place, I apologize, but I can't see any more questions.
No, there are no more questions. That's it.
No more questions. And I've got an announcement which I'll make. But first of all, just to say thanks from the Institute to Mike and Tim, remote sensing application consultants. It's been a great talk, and it's been recorded, so it's there for posterity now, and for members to look at in the future. And the announcement is that the next talk, which will be the 66th, is on the 16th of December, and it's the subject, something called AFTRAC. It's covering solar microgrids in Africa. And that project was the winner of the £1 million Milken Motsepe Prize for Green Energy. So that looks like a really interesting project to tune into on the 16th.